Good morning, folks. Running a bit late today because I'm having some technical difficulties, which I hope will not impact today's puzzle. But we're here and ready to get started on Advent of Code in F#, day 4. So we're running 10 minutes late, so there goes the speed record. But that's not the goal of this series, so I don't mind. Day 4, Giant Squid. Let's get down to the exercise. We are already almost 1.5 kilometers below the surface of the ocean, already so deep that you cannot see any sunlight. What we can see, however, is a giant squid that has attached itself to the outside of our submarine. Maybe it wants to play bingo? Okay, yeah, we know what bingo means, cool. Oh, we are going to actually play bingo. Interesting. Bingo is played on a set of boards, each consisting of a 5x5 grid. Yes, numbers are chosen at random, and the chosen number is marked on all boards on which it appears. If all numbers in a row or any column are marked, that board wins. No diagonals. Of course, we have a bingo subsystem in the submarine to help passengers, which is me and the giant squid, pass the time. It automatically generates a random order in which to draw numbers and a random set of boards. Okay, makes sense. Start drawing some numbers. What is marked? Okay, yeah. They're highlighted. Shown here, adjacent to save space. Yeah, sure. After the next 6 numbers, still no winners, cool. Why is 24 a winner? Third board wins because it has at least one complete row or column. Oh yeah, top row. Okay, so we are going to play bingo. Calculate the score. Start by finding the sum of all unmarked numbers. In this case, the sum is 188. Multiply the sum of unmarked numbers by the number that was just called. So the final number. We need to keep track of final number. We need to keep track for every number in the board, whether or not it has been marked. And we need to be able to know when the bingo round has completed. We should figure out which board will win first. Isn't that cheating? That is cheating. We are cheating against the squid. I think that's a bad idea. How will we get started with this? What would the best data structure be for something like this? 2D arrays might work. Maps might work, or lookup tables. What do we need to do efficiently? Just mark stuff, but that won't be too difficult. And detect win conditions. I think it makes not that much of a difference for today's puzzle. Although the weekend puzzles do tend to have the tendency to be a bit more difficult and take a bit more time than what we're used to during the weekdays. So it might be that this will contain some number crunching. I'm gonna grab our input first. What is that? 1, 2, 3, 4, 5, 6. We have 100 different bingo boards. And how many numbers? Something like 100 numbers. Oh, that's not too bad. Let's not worry about performance at all just yet. Yeah, I was thinking maybe do the parsing first so my brain can wake up, but actually when we do the parsing, it makes sense to already kind of have an idea of which data structure we will be using. Rows and columns, easily accessing rows and columns. I think an array, 2D array might work best. Only thing I'm not sure is how to update an array, or no, not update, but I have a personal constraint. Maybe I have not even explained this on stream, but I have a personal constraint to only use immutable data structures or no mutable variables. just as an added challenge for myself. And there is like a 2D array concept in Sharp. Let's see if I remember the syntax here. Array 2D, something, something. Yeah, let's just try it out real quick. So say we parse it into a array 2D. So this is a 2x2 matrix. Remember the syntax here. Array 2D, something, something. This is a 2D matrix. Oh, sorry, something was happening off screen that I was seriously throwing me off. So this is a 2D matrix. And you can easily select, let me give it a name. And you can do stuff like array 2D, if I can type at least. Get me the value at something, or you can even use the indexing, I think. So at the value, or give me the element at 0, 0 should be a 1. Maybe you don't need a function for that, yeah. So yeah, so that works, but you can also say fancy stuff like give me every row, give me the first column. So it should give me a vector of 1 and 3. Yeah. So I think this will work to select rows and columns really nicely. Only thing I'm not sure is how to update this thing. So let's see. How do we update an array 2D? What do we have on the array 2D module? Yeah, we could map. What does a set do? Set is given an array, 2 indices and a value, but it returns units. So this is actually a mutable or destructive operation. If you use set on 0, 0 and set it to whatever, 1, 3, 3, 7. What? It takes the array as the first argument? Really? That is a weird pipeline decision. Maybe because it's not the preferred way to do it. So this works, but then your original matrix has been updated. I don't like that. So let's do a quick Google whether or not we can do array to the immutable or Sharp. If we can have like an immutable version of this. There are people that have the same questions. Sorry, what are they doing? They're doing custom. They're writing their own arrays. Let's not go that route. I'm gonna give this 20 more seconds if I don't find what I want. I'm just gonna use a map because I know how to work with those. These are arrays. Where are the multi-dimensional arrays? Array 2D, where are you? This is not the array 2D. Is it? Yeah, okay, there we go. Multi-dimensional arrays. We could do like a update function that copies the entire array, but I don't think that will be very performant. If you look at how lists or immutable lists and maps are implemented behind the scenes in F#, they are implemented in a like a smart manner that don't copy the whole list when you update a value. And I think if we will do this, we won't have that magic. So I don't really like this. Yeah, okay, this is a nicer syntax to update stuff in an array. This was actually why I was looking at arrays. Those slicing operators are cool for selecting rows and columns. I am seeing like all these headers, updating arrays, search arrays, but I'm not seeing like a table of contents. You can even do aggregation functions on arrays. Did not know. Oh, okay, on 1D arrays. Okay. Nope, don't see it, so let's not use array2ds today. To get started, let's use a lookup table or a map. And my formatter is not awake yet. That's too bad, but okay. So, decision made, we're using maps. First thing we can do is parse the input. What do we call the row of numbers? Numbers, I guess. So we have a random order in which you draw numbers and a random set of boards. So let's just parse the boards and the numbers. I'm thinking, my brain is like a step ahead, thinking about how to represent this. So it's a map, but a map containing what? A map containing a type containing the number and knows whether or not it has been marked yet. That would work, I think. We also kind of need to know the row and a column that a number is in. Of course, because we need to know when a row or a column has been filled out. Okay, let's start parsing. No, let's grab the example. It's always more fun to work with than 100 different. Let's see if this splitting stuff still works. I think it does. Yes, it does. Okay, let's start parsing this. Okay, first thing we can do is parse the numbers. They are on line 1. Okay, let's split on comma. And let's... What is that? Array? I think it's array.map. And parse those numbers to integers. There we go. 749. That looks correct. And now to parse the different boards, let's first split everything else. I think we can do array. Does array have a tail function? Yes, it does. Or let's just skip 2 lines, so we drop directly into the first interesting line. How can we split this up into... There's like new lines or empty strings in there. How can we split up this single list into different lists every time breaking on an empty string? I know how to do it for strings. But how do we do it for arrays of strings? Or should we not have arrays of strings and work on a single string until we know the different boards? I'm liking that idea. So let's get rid of the string splitting. I'm also going to get rid of the... That was a bad idea. Let's do the trimming later. So it's a single string. Oh, you know what? Actually, let's revert and split on not new line, but double new line. Will that work? Is it not showing me? Come on, show me what example contains. Okay, that does not look correct, right? Oh, sorry. Yeah, example should contain the... Is it a no? Carriage return new line? What's happening here? Sorry. What's happening here? It's not really splitting anything. So this actually does split something. Yes, it does. But it splits too much. I feel my brain not being awake yet. It's really interesting to notice. I never like start work at 6 o'clock in the morning because it's 6 o'clock in Belgium. And I noticed that it's not all functioning all that well. Interesting observation. Come on. Why is this not working? Why can I not figure out how to split onto empty strings? Could do something with take while, you could. Don't want to. Actually, we know it's a 5x5 grid, right? Even in the final input, it's a 5x5 grid. Are they all 2-digit numbers? Yeah, okay, but we could do like 5 rows skip, 5 rows skip. That could work. Do I like that approach? I would rather just split on new line, actually. What if we get rid of trim? Is that what's confusing me? So yeah, okay, there's some ugly stuff in there, but that's not too bad. No. Okay, anyway. We will go down the route of take while, I think. Yeah, why not? So this is the grid. Then we can take five rows, I guess. Which is, yeah, an entire grid. Or an entire, what's it called? Board. Board, yeah. So that's the first board. Or at least the strings representing the first board. And the rest is example array.skip. What is it by now? 2 plus 5, 7 plus 1 is 8. So this should be the line with 315 in it. Yeah. What does 8 represent? 3 plus 5. And 5 is the... And we need to do plus 5 every time? Yeah, something like that. Oof, that's... If someone knows how to do the string split, that would be helpful right about now. Or like the split this string into board, 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 board. Okay, so let's parse a single board then, which we have here. Into a map, that was the plan. I'm just going to use a list comprehension. Yeah, why not? How do you do that again? Is it 4? Does that work? No? Yeah? Yeah, that works. So that's a line. We should also split every line into columns. Under what, tab or space? What is this? What character are you? Multiple spaces, I think. Let's try to do that. Let's see what this looks like. Oh, that looks actually pretty clean. There's sometimes an empty thing. Yeah, that's because we split on single space. What happens if we split on tab? That's not what we want, probably. That is not what we want. 2 spaces will also not be what we want. Nope. Okay. So let's split and get rid of the empty lines. Is it always an empty string? It's always an empty string, right? Yeah. Okay, so we have this. What does accept do? Is it filter out all occurrences? Returns a new list with the distinct elements of the input list. Distinct, I don't like that word. Or a bingo card probably has no duplicates. Yeah, it doesn't have any duplicates except the empty string. Let's see whether this works. Do we have a line with multiple empty strings? Yes, we do. The 8th line. So let's see if we try to take out empty strings. Do we get where we want? Word. Array, sorry. That appears to be what we want. That appears to be what we want. And then let's just map to integer. Now we are in the numerical world. We are in the numerical world, cool. We need the indices if we want to go down the map route. Yes, we need the indices. Or we can do that later. No, let's do that now. So this will be the row number. These are the columns. Can I do let in a for comprehension? You sure can. Cool. Now I would like my auto formatter to actually do something actually. Why are you not formatting my document? Why is the format document quick link not working? Do I need to select text? No. Okay, never mind then. So columns should give me an index. 0, 1, 13. Yeah, that gives me the index column. So we have the column index and the number itself. And then we can parse that into whatever we want. No. Yes, I know. Thought you could nest for comprehensions, but maybe not when you do a... Ah, that was a trick. I always get... I'm not sure what the arrows and the do keyword mean, but I know that when things don't line up, I change them. So let's... No, let's just save row column. I'm thinking, should we... Does it deserve its own type? Yes, I always get confused between row and column, so let's prevent that. Position is something with a row and a column. So now let's make a tuple, or a pair, sorry, with the row being the row, the column being the column, and the value being the number. And if you're in value world, you need this, and you need a semicolon. Whew, there we go. Row is not defined, sorry. Sorry? What is it even saying? Row is not defined. I can see it here. Is it indentation? That's not really working. What's happening here? So my editor knows what's up, but my compiler does not. That is something I can't explain. What's happening here? Okay, let's see what's going on here. Does it know about the column? Row is not defined. Where are you picking up row? Line 31. Oh, sorry, the record label row is not defined. It does not know about position. Whew. The REPL, the writing software using a REPL is fun until you hit stuff like this. If you don't send like all, or if you don't compile all your code all the time and just send snippets of text somewhere, sometimes you get into this Frankenstein state. It's really cool for fast feedback, but it's not cool for this exact reason. But yeah, so I think we're parsing, we know row columns, we are ready to put everything in a map. We are. So I think you can just pipe this into a map. And we have a first board. Yeah, we have a first board. I'm already regretting several of my decisions. The map thing, lukewarm on that. If I look at how I have to parse this because I don't know how to split on empty lines. Not proud of that either, but it works. Or at least it works good enough. Now, how do we parse 3 different boards? Let's maybe first give these the names that they deserve. So these are not numbers text, these are the actual numbers. This is an actual board. No, these are the board lines. This is the board. Why is my auto indent tool not working? I was actually getting used to it and liking it very, very much. Let me take a quick look. What's happening? I know there is an F-sharp formatting menu somewhere. Yeah. No, it's an F-sharp tools thing. Yeah. Formatting. There we go. It still exists. So why is it not triggering? Oh, I opened this menu and it starts formatting in the background. That is really weird. But it screwed up everything. What happened here? What happened here? Whoa. It duplicated everything. What? What is this? Okay. I'm happy it works. I'm not happy it did this. Let's Control Z, Control Z, Control Z. Let's go back to right before we format it. Oh, now, okay. Don't touch anything. Yeah, it's back. No, it's not back. It indented a bit too much. Or does it only look like it indented too much? Yeah, it looks correct. Let me grab something real quick. Okay, I'm happy that the formatting works. I'm not happy with how it kicked off, but it works. Cool. So this is a single board. These are the other boards. Yes. So let's recursively parse boards. Yeah, let's recursively parse boards. tail recursion, that's not really relevant for parsing 100 boards. I'm not gonna worry about that. Board lines, what actually is that? An array of strings, but maybe if we do the actual function call, type inference will know what to do? No. No, of course not. Okay, that's because type inference happens from top to bottom, apparently. So let's give it a hint. It's a sequence of strings. I don't know why I kept it in the array world, but let's keep it in the array world then. So this should work, and it should parse the first board. Yeah, it still does. But we would like multiple boards, and we decided to do this with recursion because I am too brain dead to figure out how to split a string. So let's do a recursive call. Parse the rest of the boards. And if you do a list concatenation, you don't need this. Yeah, there we go. It gives me a list of maps, and a map is a representation of a board, so that sounds correct. Oh yeah, we're in an infinite loop. How do we detect the end? What actually did it crash on? Let's do that again. I'm curious what it actually crashes on if you have an infinite parsing. Oh yeah, it threw away the entire interactive session because of that crash. Clear this screen up. Let's do that again. What is the actual crash? It's saying Stack Overflow makes sense, but what are you Stack Overflowing on? On string splitting. Interesting. It's crashing on this line. Huh? What happens if we reach the end? It's a sequence of strings, so sometimes down the line it has to. Is it 8? Do we have to skip 8? No, we don't. We have to skip. If we give it board lines. Board lines should start at the first line of a board, right? Oh, board lines is already... Okay, board lines is already a sequence. That is not the rest. Okay, let's do it differently then. So board lines is the entire string starting with the first line of the board, and then it'll do what I am working towards, and we should skip 1, 2, 3, 4, 5, 6 lines. So 5 for the grid and an empty line. Yeah, makes sense. Now we are doing what we expect, and if the... I think this might blow up on the last board, because there is no 6th line. There is no white line on the end. I'm just gonna shuffle the input, fit my purposes. Not gonna worry about that last case. Or an advent of code puzzle at least. Let's see if that works. So if we have an empty sequence of strings, then we don't do anything, and otherwise we do the recursive thing. Does this work? Nope. It appears to be Stack Overflowing still. This is like not the hardest part of the entire exercise, parsing the grids, but it's already proving to be too much of a challenge for me today. That happens. Just gonna try one more thing, which is adding an explicit new line. And then I'm gonna start debugging, figuring out what my assumption is, or what my incorrect assumption is. Still overflowing, still overflowing. Okay, what's happening? Let's get rid of the white lines. That was a bad idea. Anyways. So is board lines what we think it is? Board lines is 1, 2, 3, 4, 5. Check. 1, 2, 3, 4, 5, check. Yeah, so it's every string or every line in this string starting from the first. So that lines up with my assumptions. Then we say parse everything. Yeah. If we don't have any more lines, we say stop. Otherwise, we parse a single board. We need to take only 5 rows. That will also help. I'm not gonna do the recursive call. I'm just gonna push out the first board. Why is that? Oh yeah. Let's see if that still works. Parsing a single board. That works. What is the rest? I'm just doing hacky stuff to make sure that it works. I could use a debugger or start printing stuff, but this also works. So this starts at 1, 12, 20. That is what we no, that's not what you expect. That's the final row. What? What? How can rest be what I'm seeing here? So this is the first board that has been parsed. Yes. And then it says, okay, here's the rest. And it starts with 1, 12, 20, 15, 19. Which is the last row. I'm using different variable name here. That is a bad idea. 350222. Now we are getting somewhat closer. But the recursive thing still is not really where we want it to be. Yeah, still not where we want it to be. So the final board does not have a white or a new line at the end. Now I am going to hack it again. Or to do something dirty-ish. Interesting. That is not enough. Okay, if it doesn't work on the first try, give up the idea. Because it is a bad idea to get started. How do we do this? It would have been a lot easier if I remembered how to split a string on an empty line. That would have been actually more fun than what we're trying to do here. Is this something Stack Overflowable? Should we? We should. I've had it with what we're trying to do. How do I split a string on an empty line? So even 10 years into my career, I'm using like C# on a daily job. I still have to look up stuff like this. This was actually, yes, this is my struggle as well. I've tried everything. This actually, I think I tried. It is the accepted answer though. Should we give it another go? And do the string split options thing? Yeah, I dislike what I'm doing enough to give it a try. What does this give us? It gives us nothing close to what we want. No, it's not splitting anything. Why is that? Maybe it would work for the input. Maybe this copy pasting a string is and using this at, this literal thing, is confusing the, or not confusing, but it's it has like different hidden characters in there. Ah, that proved to not be the case. Oh, come on. Oh, come on. This should not be the part of the exercise where I fumble and fall. How do I explain this not working? Let's do the professional thing and literally copy paste what we see on Stack Overflow. Try that. So that's a string array that has a bit of a different syntax. It's oh, that's not the pipe character I need. This is okay. And it's a system.string split options. There we go. Okay, I give up. No, I give up. I wasted enough time on trying to do the clean thing. Let's continue on with our hack, or our not so clean thing. So what was the problem in our not so clean thing? This 6, don't like it. If we take 5, it will work, but then we will end up with an empty line here. So let's skip that empty line. Oof, this is becoming an unholy, unmaintainable mess. Let's put this parsing code deep down somewhere in our system so nobody has to take a look at it again, and then it's okay. No, I thought we were finished. Well, what line are we crashing on? It's not saying. Interesting. It would be helpful to have a stack trace right now. Okay, let's just print out what we're doing then. Let's just dump the entire input we get to console. So that's the first one. We parse the first board, and then we have this, yes. And we should be skipping that empty line and continuing how we were. Oh yeah, then of course we do need to skip 6. Oh, oh god. Oh dear. Okay, let's make this thing smarter and do 6 or 5 depending on the length of board lines. Don't like this, don't like this. But it's something to fix with a clear mind. There we go. Seeing that it's not the meat of this problem, I'm just gonna chug along. You see this little minus sign here? Click it, and all the dirty code in the world goes away. That's how I solve my problems. At least at 6 o'clock in the morning. Oh dear, we're already running an hour in. Anyway, we do have our boards now, so we can get started with the actual fun. So let's grab numbers and let's grab boards. Whoa, that's something I didn't expect. My minus button does not really work when formatting kicks in. So let's not hide it. Okay, now we can get started with the actual exercise. Cool. So we have our numbers, we have our boards. Now every number that enters, we mark the number up until a moment where one of the boards has a full row or a full column. Complete row, that's the term we use. Cool. And then we do magic. So one more thing I want to do before we do all that is we don't only need the number, we need to know whether or not it has been marked. So next to a position, let's define a record type called number, whatever, with a value and a boolean representing whether or not it has been marked. And then we can use that as a value in our map. That should work. I think data structure wise we have everything to solve the problem. So let's start marking the boards and let's start figuring out whether a board has been or whether a board has won. Which would have been really easy to do in a 2D array. Sorry. But because of my stupid or silly constraints of not having mutable data structures, it will be a bit more tricky. I'm thinking back on last year. There were a lot of grid-like puzzles as well, and I remember using a 2D array. And I had the same constraint back then, so let me go back to my code from last year. Advent of Code 2020. I'm just gonna take a look at how I did the array to do 2D thing back then. Day 20. Apparently I solved day 20 using 2D arrays. Oh, that was a very interesting puzzle that took me, I think, 8 hours to solve. I hope today's puzzle will go faster because I'm not ready to spend another 8 hours of my life on stuff like this. So, array 2D. I did the actual copy the entire array. Yeah, I always copy it into a new matrix. Okay, that is something that you can do. I don't think it's the most performant way to do it. Performance is never a problem in Advent of Code puzzles, so yeah, it might have been a valid alternative. But I'm stuck with maps now, and I'm going to stubbornly stick with them. What will we work on first? Marking a number? Yeah, let's go outside in, let's go top down and write the solution solver from a top down way. So we have parsed everything. I'm seeing that word lines is missing from this thing, so let's grab that. Everything is close and neatly together. Just gonna inline this variable because it's this close to where we use it. I don't want it anymore. and that will make parsing our real input. Yeah, that's maybe something we can do. Let's try this on our real input as well. So let's write a parse function. And let's call our parse function on the example and on our input. And instead of example, we should use our argument, and we should return, let's make it a pair or containing the numbers and the boards. And text, what is a text again? A string array. That should still work. Just refactored, yes. And it should maybe also work for input. Yeah, it works. The actual parsing is fast. It's the printing to console that's slow most of the time. You see like things chugging along in your FSI window. It's printing, or at least for stuff like this. So top-down solve function. Yeah, whatever we did up until now, I'm not going to write any tests for that because I've seen my formatting code for long enough now. So let's try taking a look at a solve function. So we get numbers, we get no, I'm not gonna write the function, I'm just gonna play around with numbers, boards. I'm gonna play around with it until I know where I want to go a bit. So what would the solve function do? It would take a number or the next number, mark it on all the boards, and then we check all the boards whether one of them has been completed. And if one has completed, we stop and we announce the winning board. Yes. If we have a winning board, cool. That's it. We return the winning board. If we don't have a winning board, we go for another round, which means taking the next number. Yeah, this is a nice fit for something recursive-wise. So, take the next number. Yeah, let's write a solve function. Let's solve numbers, boards, equals, and let's pattern match on numbers. Or actually, we should always have numbers, or we will have more numbers than we need to have a winning board, I hope. So I'm gonna do let n is number, so we have the first number, and then we mark that number on every board. So that is a list of boards, so we can do list dot map, and we map a function called mark, which we don't have yet, and we mark the number. And then we look for a winner in the marked boards. If we have one, that's it. And otherwise we recursively do it with the rest of the numbers. Already thinking about type signatures here. Let's write a function mark. Mark a number on a board. It should give a new board where the number has been marked. And winner should be it takes boards and it returns a, it's like it can have a winner or it can have no winner, so I'm going to go with an option. Yeah, I'm going to go with an option. How do we do the, do we have a winner? Just pattern match? Yeah, I'm too tired to think about clever ways, so I'm going to pattern match on winner. If we have no winner, we do the recursive call. If we have some winner, we return the winner, and that's the actual board that has won. In the none case, we solve using the rest of the numbers and the marked boards. And in order to recursively call a function, you have to declare it recursive. What happened now? Sorry? I press save and this happens? Really? Incomplete matches on this expression. For example, the value empty list may indicate a case not covered. That is very correct, but I know it's never gonna be. This is confusing. Okay, let's not do this. I know it's valid syntax, I know it works. The warning is a warning, but I don't know why the auto formatter is not liking this. Maybe if I put parentheses on it, and otherwise we'll split it into multiple statements. Okay, this works. So if we now call solve with numbers and boards, which we parsed, boards, list array. Okay. Yeah, that's true. I'm gonna make the numbers a list. It's more fun to work with. And I'm already going to do it in the parsing stuff because reasons. There we go. Yeah, this should actually work. It shouldn't do anything useful, but it should try to mark boards, which is like an identity operation, and it should try to find a winner, which it never does. So it will crash on this pattern match. That's at least what I expect it to do. Or it won't even run because it doesn't know what to do with the type. Cool. How does it not know that winner is a board? Oh yeah, because we return none. We should... type inference cannot figure out the return type of winner or the correct return type. It knows it's an option, but it doesn't know an option of what. It can't resolve the T type parameter. Okay, I think mark will be pretty easy to implement, so let's do that first. Let's maybe even... Yeah, let's just do that. So board and number, and it should find the number if it's in the board, and it should update the marked boolean to true. Why am I putting everything in a map actually? It makes no sense, maybe except to figure out rows and columns. No, I should have gone for array to do. Wrong data structure makes problems that much harder. Lesson learned, I guess. So, okay, let's mark. Board is a map. What can we do with a map? I don't need to do like a location-based lookup, so all the fine things are actually not that interesting. Yeah, we could flatten it again and update, but I think that might be one of the only ways to actually do it. Yeah, this data structure was a bad idea, but okay. Let's just map over every value. It takes a function mapping, which takes a key, a value, and a new value. So it should take key is a position, and the value is a number. Let's type that out. And what should it return? The new number. So this should actually work, right? Yeah. So we're mapping over every value in the map. That's a confusing sentence to say out loud. Actually, we don't care about the position. We care about the number. Value is v. I'm just going to destructure this value marked. Okay, so now that I'm typing it out, we don't need to. So if the number dot value, that's also a way you can do it, equals the number, then we update the number if marked is true, and else we just leave the number alone. I think that's something in the lines of what I want to do. Sorry. Oh, I have a duplicate variable name, so it's number 2 mark, for example. There we go. So go over the entire board, and for every entry, if we see the number, we mark it, and otherwise we leave it alone. I think that might actually work. I'm just gonna quickly test it out because reasons. I feel like testing this. Let's mark something on a board that doesn't have the number. That should work, and leave everything alone. Or let's yeah, this works. Let's make a map. Let's grab this and put it down to where we know how to run tests. No? Oh yeah, it needs like something to compare it to. Seriously, I would have expected it to infer the types of an empty map. This also has a problem. Why is the IDE not having a problem and the REPL? Okay, there we go. It has a problem. Okay, so that works. Why does this not work? It has been inferred to have generic type. Okay, let's put something in that map that will help. So it's a position and a column, and it has a value and is marked or not. And I should keep using equal signs instead of these semicolons. There we go. Does that already compile, do something? No. Is it not column? Col. Okay. I thought it was nice and symmetrical to have 3 letters for row and col, but apparently it already confused me, so no, bad idea. Still not happy? Oh yeah, because it's it's now complaining because whatever you put inside a test quotes or quoted expression has to be it has to evaluate to a boolean, and right now it's evaluating to a map, so that's why it's complaining. But if we select this and make it a map, it's already becoming an unreadable blob. So auto formatter, help me out here. That's not better, but okay. That at least should work. This is the... Sorry, how can you not know about test? Yes, no, maybe? There we go. So this is the case where we mark the number in the board. Let's write another test for the mark number 5 and then, or 6, yeah, whatever. It should remain unmarked. And especially not crash. Cool, that works. I think marking works. Next step is determining the winner. And that's the only part of the problem where the data structure kinda would have mattered more than, or where it would have mattered the most, and that's where it still won't help to use a map, because we need to figure out the lines and the columns, and a lookup table has zero benefit for that. So yeah, bad decision. Winner boards. Let's just use a list.tryFind. If you look at this method signature, the function signature, you give it a predicate and a list. So we have the list of boards. The predicate is hello. Is this board I'm looking at a winner? And it just keeps going over the list. If it finds a winner, it returns the winner in an option. And if it doesn't find any winners, it just returns null, which is, it lines up with the types we want. So that would just work. So boards, list, try find. And then we have a predicate called isWinner that works on a single board. Let's write that as a separate function. And that should return a Boolean. So we broke down the problem into another step. And this is the smallest step that makes sense for me. So let's implement this. When is a board a winner? If any of the rows or any of the columns contains only marked numbers, right? Right. Let's just focus on the rows first. It's making my brain go bzzz. The fact that I use the map. It's not even not helpful, it's counterproductive. So we have to go over every row and then do a lookup because it's a map and that sucks, but we're sticking with it. I'm stubborn like that. So yeah, let's, we know that the rows are, what is it? 0 to 4 probably. So I'm just gonna do a for comprehension again, a list comprehension, sorry. So for row in 0 to 4. Yeah, the map is totally useless. I'm just gonna get rid of the map in here, or I'm gonna keep it in the types, and I'm just gonna throw it away in here and just do a list.filter. So then it's a tuple of a position and a number, and if the position dot row equals the row, we have the all the rows. Yeah, I think that makes sense. No. Oh yeah, actually we do. So for every row, filter out the cells in that row. I need to see this in action. Let's call this rows. What is this rows thing? It's a list of a list. Oh, yeah, for every row, it's a list of numbers. And if we make that a list of booleans, should we do that in one step? No, let's not do that in one step. So these are all the rows. I think we can also do the same for columns. I think if I look back at this code a year from now, or even 3 hours from now, we can reduce the size to, I think, a fraction of it, make it more clear. And the only thing we have to do is learn how to parse strings and use the correct data structure. Simple as that. But first, let's solve today's exercise with a stubborn map approach. So we have our rows, our columns, and then we just have to look, is any of these only marked values? Yeah. So there is something like a union, no, what's it called? Concat? Yeah, append. There's something to concatenate two lists. Yeah, this is the thing I'm looking for. So all rows, all columns, and then do something. So this is either a row or a column. I have no concept for that, or no name for that concept. How do you call something that can be a row or a column? Maybe a vector? Yeah, let's call it a vector. So let's map every vector to whether or not every number in there has been marked. Marked, I think. Does that work? No? Yeah, it's not a vector. Yeah, it is a vector, but it's... Okay, the types are throwing me off. Step back, step back. What actually do we have inside vectors? It's the position and the number, and it's a list of a list. Or no, but that's what we're stuck with, so yeah, that's what we're gonna do. So for every vector, I'm gonna take it really slow and do step by step. So for every vector, which is the position and the number, map it to the number dot marked. Yeah. What's it saying? Okay, let's assign it to a variable. Wait, single vector. Oh yeah, a vector is a list of things. Yeah, I was actually correct a second ago. Or at least that was more correct. So every vector, let's map that single vector to... And that's where the position and the number come into play. And we can map to number.marked. Yeah, so that's now a list of bools. So for a single vector, we can do something more, which is a list for all. So for all tests if all elements of the collection satisfy a given predicate. So I think we can even do this, put that here. Say, okay, dear vector, do you have for all the marked property? And then we can just say a list.exists here. I think that's actually what we want. We won't know which line or which column, so I hope we don't need to know that for part 2. But I think this works. So what are we doing here? Collecting all the rows, and it's sucky because we have a bad data structure. Collecting all the columns in the same way. Smooshing everything together in a single list, and then going over every row or column and saying like, hey vector, or hey rows and columns, is there one of you that has only marked cells? And if that's the case, we have a winning board. And otherwise we don't, and this none, or this try find will return none, so none will do a recursive call with the rest of the numbers. We have not seen this working yet, but I'm feeling super confident. I'm not. Okay, cool. What's the problem? Duplicate definition of winner. Yeah, it's true. Let's call this try find winner. Does this function deserve to exist if it only does a list or try find? Nah. So let's grab this. And let's replace the function call with the implementation. There we go. Cool. I'm just gonna select the whole shebang. Oh, it appears we have a winning board. We should. It's the one with the 14 in the top left. Yay, that looks correct actually. And is the entire top row marked? Marked, 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 marked. Yeah, that actually looks correct. Cool. So it's terrible code. We have to rework this entirely if we want to make this more understandable, but it appears to be working. So let's just finish part 1 and see how much of a change part 2 asks for us. Score of a winning board can be calculated. Let's go. Start by finding the sum of all unmarked numbers on the board. We can do that. So unmarked numbers is winner, and again we have to get rid of the map. Or no, we can do map dot values. And then what does that actually return? Generic I collection. I've never seen that type in F# world. Can I do a sequence dot on it? Sequence dot map? Yeah, that works. Okay. So we get everything. We grab the values from the board. We map onto... no, we filter on the unmarked thing. So grab the unmarked numbers and then map those. So these are all the unmarked numbers, and then we need to sum them together. 188, yeah. And we get the multiply the sum by the number that was just called when the board won. Or we need the final number as well. Okay, we can do that. So that's actually n in our solve function here. So instead of returning only the winner, let's return the last number as well. So last number and winner. And that should be 24. And unmarked numbers should be sum of unmarked numbers. So, whoa. Okay, that's my auto formatter kicking in. Last number is 24. Sum of our unmarked numbers is 188. Yes. And then we need to multiply. Multiply with the sum of unmarked, which gives us a big-ish number. Yep. And now we need to run this on our code. So solve is actually not solving the problem. It is getting the numbers or getting the winning board and the last number. I'm thinking, how do we run this against the input? What do we need to change? I'm just gonna wrap everything in a function. So this, where do we get numbers and boards? Where's the parsing happening? There we go. Let's grab that as well. And let's get down here where we are solving the example. So this is, solve is not the best word. Let's call this find winning board and the last number, but okay. And now let's write a sum, solve for some input text, which does everything here. So we parse the text, we find the winning board and we do the multiplication thing. Yeah. So solve this, for example, should give us the same 4,000 something something. We refactored or renamed this method. Yeah, so that works. Let's run it on the input. Okay, that also spits out a number, but is it the correct number? Dear, making a quick silent prayer. I don't want to troubleshoot this code. Okay, at least for part one, it's good enough. That's a very small part too. Let the squid win. I think that's actually a better idea. Cheating against the squid, you might want to let him win. How many bingo cards a giant squid could play at once? How many tentacles does it have? 8? Rather than waste time counting its arms, the safe thing to do is to figure out which board will win last. Which board will win last? And choose that one. So from my set of boards, or from the entire set of boards, pick the worst board. And then we'll play with that one. Yeah, that's true. If you were to keep playing until this point, the second board would have a... Okay, so we need to actually do exactly the same thing, but instead of stopping when we find a winner, keep going, throwing out winners until we get the final board that would be filled. Completely dead last. That sounds like a small change, and even with our horrible parsing and our horrible data structure choice, sounds actually pretty doable, so I'm not gonna refactor just yet. I am going to soldier on. It's my usual approach. Forget about part 1 when I start part 2, so don't have to worry about what came before. So instead of stopping when we found a winner, we continue until we only have the one board. And when do we actually need to stop? Do we need to solve the last board? Yes, we need to stop when that last board has 1, so we know the number. Okay, everything is still working. So actually find winning board. Let's just rename this. I'm gonna massage this function so it... Or actually no, it'll still give the winning board. No, this is our game loop, the recursive thing. That should not stop at the first hit, it should keep going. So if we have a winning board, if that was the last board, then we're good. This is still the case, but if we have more than one board, we should throw away that board. And continue down the numbers, right? Right. So yeah, this is actually the losing board. Oh no, that's gonna be confusing. Because actually it is looking up... Oh no, it's looking up is winner. This will work. Find losing board. So this is now... Losing sounds bad. Find last winning board. That's better. So it'll return a winning board, but it'll be dead last. We still have to go over the numbers. That is correct. We still have to mark. Yes. Then we try to find a winner. You know what? No. Yeah. Yeah, I'm thinking like we can stop earlier. No, we cannot, because we have to fill in that last board until it wins itself to figure out the last number we draw. So actually we all have to do everything here, but except in this case, if we have more than one board, throw away the winner. It's confusing me because every function call will... What is confusing me is that we're looping over the numbers, but we're also editing the list of boards, or at least we will be editing the list of boards. It's getting tricky, and we're already coding for 1.5 hours. I'm gonna give it one shot. If it doesn't work out first try, I'm gonna take a quick break. But let's give it one more shot. So, match winner. This actually means that a board has won. Yes. If no board has won in this round, we just continue on as planned. Yes, that's still true. If we have a winner, that's when we need to do something more. If boards... If we only have one board, then this is the last winning board. Sorry? Why is this not working? What's it saying? Oh, it needs the parentheses. Okay. So if we only have the one winning board, then we're done. Otherwise, we need to do something more, which is... Let's make a new list of boards without the winner, which is marked. Remove at. No, I want to get rid of an element and I don't know the index. Except will work. So everything except the winner. And we do the recursive call. Yeah, there's two cases where we do the recursive calls. One is we have not found a single winner this round, so we just keep going. One is, oh, we have found a winner, but it's not the last one, so we also keep going. I think this is it, folks. I think this is it. Let's try it for the example. Just to be sure, I'm going to select all the code in existence because I don't know what I sent to the rebel. Sorry. 1924. Is that what you expect? Oh, that is what you expect. Cool. Oh, match cases were incomplete. Match cases were incomplete. What are we matching? This? Oh no. Oh no. It appears we have run out of numbers. I hate it when it works for the small demo example and when it doesn't work for your input. So it works for, or it appears to be working at least for the example, but not for our input. Okay, we're almost there. I'm feeling confident enough to hack some more to finish this. Or what's probably blowing up? This is probably blowing up. Probably. Let's print out the numbers. So we can figure out what's happening. Oh. Oh yeah, actually it has an empty list. Is 10 the last number in our input? Probably it is, because part 1 worked. Yes, 10 is the last number. How can this happen? Let's also print out the boards we have. I'm not seeing it. Slowly but surely we're going down the list of numbers here. Very slowly but surely. Yeah, it just keeps going and then it booms. How many boards do we have actually? Do we need to throw away the winner somewhere else? Yes. Oh dear, that's the problem. We never throw away we throw away winners here when we do a recursive call, but we don't throw away winners here. So let's also grab this beautiful line of code and throw away the winner. Oh, actually, no, we have no winner. No, we shouldn't actually throw away any winners here. When we don't have a winner, we don't. I'm not going to print out the boards. I'm going to print out the number of boards. See if that decreases. My stomach is telling me it's time for breakfast, so I hope we figure this out soon. It appears to go down, right? We're like at 100 here. Yeah, but somehow we end up with still, let me find my page down key, 34 boards and our numbers run up. That sounds like a potential bug in our marking, which would be surprising because part 1 also does the marking. Yeah, this is going to take some really boring troubleshooting and really boring debugging. And I'm going to do that after another cup of coffee and a healthy breakfast. Some avocado toast, something like that. So I'm gonna quit the stream here. Refresh my mind, solve the problem using this dirty map-based solution. And even after that, if I find the time and energy, we might actually rework this to something nicer. Because, let's face it, it was a horrible decision to use lookup tables for today's problem. Also, I need to learn how to parse strings. Cool. Have a good rest of the evening or a good morning, good weekend even for you, and I'll see you next time. Bye-bye.